So far, we've worked with entities that map to tables and can be updated by EF-Core into the database. Keyless entities give us another way to map entities so that EF-Core will always consider them to be read-only. But what's really special about this feature is that it also allows you to map to views and tables that have no primary key. There was a time when Entity Framework Core had no way to work with entities that don't have a key, and that's because the change tracker relies on those key properties. But now EF Core can comprehend keyless entities, and it won't worry about needing to track them. Keep in mind that if you want to have the flexibility of an entity that can sometimes be updated and sometimes be read-only, you can still use the no tracking queries or specify the query tracking behavior from the DB context. There's also another feature that lets you map an entity to both a table and to a view at the same time, and EF Core will use the view for querying and use the table for updates. I won't be spending any time on this feature, but you can find a link to more information about it in the resources for this module. The feature we're focusing on here, the keyless entities, is more about being able to have entities with no keys, and therefore they're always read-only. And because one of the great benefits is being able to map them to database views, it's time to add a view into my database. The editors recently requested a way to get a list of their artist pool and find out which authors they've designed book covers for. So the team decided that a database view was a great way to get that list and asked their database guru to work out the SQL for a view called Authors by Artist. And then someone on the team used migrations to make sure that gets into everybody's development databases. Here's a look at querying the view directly from the database so you can see what the results look like. It returns all of the artists, and if they've worked on any books, it lists the authors of those books. Some, as you can see, haven't even worked on any book covers yet, so their authors are null. The keyless entity need only match the schema of the view results. So that means I need a class with two strings, artist and author. And because author might be null, I'm specifying that this property can be a nullable string using the syntax of appending a question mark to the string type. And of course, there's no key property in here, just the two strings. Now I can create a DB set to make it easy for other devs on the team to write queries. Here's the new DB set in my context, and I gave it the same name as the view, Authors by Artist. There are still two more steps for configuring this, but I want you to see what happens if you forget to perform that step, because it's really easy to miss, but the compiler won't catch it. EF Core will catch it at runtime when it's trying to work out the data model. So I'll go ahead and add a query against this new DB set using toList to execute it. When EF Core tries to build the data model at runtime, it throws an exception. In fact, if I had just used the visualizer from EF Core Power Tools, I would have been alerted to the problem as well. So remember to take advantage of the tools that you have at your disposal. The exception says that the entity type Author by Artist requires a primary key. And it's even more helpful because it also tells you that if you meant this to be a keyless entity, then you have to add the has no key mapping in the DB context. So let's go fix up pub context. In the onModelCreating method, I've added a new mapping to the model builder for the Author by Artist entity using the configuration method has no key. But there's another problem which right now is invisible. By default, EF Core maps all entities to tables, and therefore it's going to expect that there's a table called Authors by Artist. And if I created a new migration, it would create logic to create that table for me. I definitely don't need it to happen. I already have my Authors by Artist view in the database. So what I need to do is explicitly use the toView mapping with the name of the view, Authors by Artist, onto the Author by Artist entity. I'm not using this to fix the naming, where my view name might be different than the DB set, although that would be another bonus, but it's something you always need with views. And because the view name happens to match the DB set name, I could avoid typos in a magic string by using C#'s name of method and passing in the dbset name, which will give me a flawlessly spelled string. Another important thing to be aware of is that this won't affect migrations. Migrations wouldn't have the ability to figure out what that view should be. That's why I predefined it and created a migration for it. So right now, even though I've just made a change to the model, it's a change that migrations would ignore. And if I created a new migration, both the up and down methods would just be empty. The other important aspect of the has no key method is that EF-Core will never attempt to track this entity when you exit queries. Remember, I said this was EF-Core's way of supporting read-only entities. So you don't have to worry about using an as no tracking query. And if you try to explicitly force tracking with the as tracking method in a query that's using keyless entities, EF-Core is just going to ignore that. Now we can finally execute a query on our view. I'll start by just getting a list of all the artists with their authors. And that's easy enough. EF-Core just creates a query against the view, and as it does with any other queries, it materializes the results and creates a list of objects, although because they're keyless entities, it does that without change tracking. You can use other link methods as well. Here I've got a query that uses first or default, and then another one that filters on the artist name using the where method. Because views are composable, EF-Core creates SQL that just performs standard queries against the view. Again, it's no big deal. And the only reason this last query isn't parameterized is because I just pushed the predicate directly into the link query. And at the end of my method, I grabbed the debug view so I could show it to you, and it's completely empty, which is expected because the change tracker doesn't track the keyless entities. And I know I've mentioned that a few times, but I wanted you to actually see that. You'll have to be careful about using dbset methods on the dbsets for keyless entities. For example, the compiler is perfectly happy with using find because it's a method of dbset, but when it's attempting to work out the SQL at runtime, it will realize, whoa, wait a minute, there's no key here, and it's going to throw an exception. In addition to querying the dbsets with raw SQL, it's possible to send raw SQL to the database for other tasks using the execute SQL raw and execute SQL methods. And like the execute update and execute delete methods we saw earlier, these are methods of the dbContext database property. But the execute SQL commands can't be used for queries. Not only can they not materialize query results, the only result you'll ever get back is the number of rows affected by whatever command you sent. Like with the raw SQL commands for querying, you can pass in SQL or call procedures with the execute SQL method. Two other points I want to make are first, that there are async versions of these methods. And second, which is just a reminder that if you have existing code with the older interpolating method, execute SQL interpolated, that will continue to work, and it is exactly the same as execute SQL. Perhaps someday it will be deprecated in favor of the simpler method name, but it isn't a breaking change. For new code, however, you should probably use the newer version. It's certainly a lot easier to say. I'm going to use a stored procedure to finally show you a handy way to delete entities without having to first pull them into memory. I've hinted at this a few times in this course, so here we finally are. I've added one last stored procedure into the database using this migration. The procedure this is creating, called delete cover, takes a cover ID and deletes it from the covers table in the database. And thanks to Cascade Delete, it will also delete any artist cover rows connecting that cover to artists. I've already updated the database with this migration, and here's the procedure listed in the database in SQL Server Object Explorer. So let's use that procedure to try out the execute SQL raw method. I'm now drilling from the context instance into its database property and then its execute SQL raw method. As before, we'll need to use a formatted string to specify the procedure and then pass in any parameters. Just one in this case, say a value that was passed in from another method. and I just assigned 9 to it, since I know that that does exist in my sample data. When I'm calling the procedure, I can use it with or without the exec statement, as you saw earlier. And here's the SQL generated by EF-Core. The value of the cover ID is parameterized in the command and then passed in when executing the stored procedure. Remember, I said that these execute SQL methods will return the number of rows affected. And here you can see that I captured that result, and the value is 1 because there was only one row deleted. If you were using a procedure which performs some action on multiple rows, that result might be useful information to send back to your user. One last but very important point about the execute SQL methods. Just like with execute delete and execute update, these methods will not interact at all with a change tracker. And it's best not to try to mix and match change tracker work with direct SQL methods that change things in the database. And that's not the case with the dbset query methods. The resulting objects from those calls will be change tracked by default.